Kicking off the waiting room, and they're all coming in. There we go.
Hi.
Hello, welcome.
Hello, welcome. Welcome to Destination Space 2021. I'm Andres Martinez. I'm a NASA engineer, and my office is not too far from your schools. Remember, today we have a very special guest with us. We have Miss Lindsay Aitchison. She's one of my colleagues with the Advanced Exploration Systems Division at NASA headquarters. And remember, the AES division is a team that's creating the plans to send humans back to the lunar surface and onto Mars. Ms. Lindsay Aitchison, prior to joining the NASA headquarters team, spent 14 years as a spacesuit engineer. She at the NASA Johnson Space Center. She's gonna tell us all about her work with the new astronaut suits that she's leading. She's a program executive, and she has been working on these suits, and these are gonna be used pretty soon. She's gonna tell us all about it, okay? So remember, in these talks, we only have one rule. All of us have to mute our mics so that Ms. Aitchison can share with us her incredible work. Okay, Ms. Aitchison, welcome. Thank you for being with us.
Hey there, everyone. Thanks for
Oh, Miss Aitchison, you're on mute. Sorry about that.
That's okay. I'll start right over. No worries. I'm Lindsay Aitchison. I'm a spacesuit engineer, and today we're going to talk a bit about the spacesuits we're building for the Artemis program that are going to take us to the moon, help us explore, and then go on to Mars. Before we jump into what we do for spacesuits, I wanted to tell you guys a little bit about myself and how I got to be here. When I was about 4 years old, my parents took us to the Johnson Space Center Visitor Center as part of our family vacation. And I absolutely just fell in love with everything about space. Probably it was watching those movies of the astronauts floating around chasing M&Ms. That looked so cool. And I definitely wanted to be a part of that when I grew up. My parents were super supportive. They let me try a lot of different things. So, you know, NASA has a lot of different jobs. And so I wasn't just super focused. I mean, I did like math and science and doing all sorts of things, but in the summer it was about seeing what I really enjoyed doing. Do I like physics? Do I like chemistry? Was it engineering? So doing a lot of different summer camps and things like that. By the time I got to college, I knew that I wanted to be an engineer. It was a lot of hands-on work, and I could do a lot of different things with an engineering degree. So I did that. When I went to college, I became a mechanical engineer, and I was able to still pursue my dreams with NASA. I alternated semesters working at NASA with semesters of going to college. And one of the really cool things I got to do as a research project, my research team and I, we got to fly on the Vomit Comet. And that's that middle picture that you see here. So that's where we simulate reduced gravity and see what it's like to float around, and also how our science experiments reacted to the absence of gravity. And then the last picture here is me on the job at NASA Johnson Space Center. Part of a job of a spacesuit engineer is actually getting inside the suits and seeing how they work so we can test them out to full extent before we test them with the crew, both in the NBL and then eventually on our actual missions. So one of the things you might be asking, and people ask me a lot, is when you're designing a spacesuit, where do you even begin? You may think the question is, how do I make myself look awesome? I'm going to space, which is a really great question. And aesthetics do matter. What you look like, you want it to look good, but really it has to be functional first. So when we're designing spacesuits, our first two questions are, where are you going and what are you doing? So where you're going, it really defines the type of protection that we need to build into our spacesuit. Our spacesuit has all of the protection of a full space vehicle, just in a smaller human-shaped package. So we have to think about What is the gravity like? How hot and how cold does it get? Is there any pressure around you? What does the terrain look like? And what's the radiation? These are all big questions that design how you do the protection that goes into your spacesuit. Similarly, we ask, what are you doing? And what are you doing really derives how much mobility do you need to have in your spacesuit? How easily do you need to be able to move? Do you walk on your feet, or are you walking with your hands? Do you have complex tasks that require you to have a lot of dexterity in your fingers, or is it more just walking and observing? These all drive how we design the mobility systems of our spacesuits. So let's have an example. If I were to say, your task is, you're going to the beach and you're going to build me a sandcastle. What do you think you would bring with you? There are a lot of different things you can think about bringing with you. What type of tools do you need? And what are you going to wear to be comfortable while you're doing that job? You're probably going to wear a swimsuit or something lightweight, maybe a pair of flip-flops, definitely some sunscreen so you don't get sunburned, floppy hat, sunglasses, and definitely a bucket and a shovel so you can actually build your sandcastle. Those are all the tools, and it's kind of how you think about doing that job. Now, if we change the environment and ask you to do something similar, so now you're still building a castle, but it's a snow castle in someplace very cold. You're probably going to be able to use the same tools, but definitely want to wear a different set of clothes. So you're going to swap that swimsuit for a warm coat, that lightweight top for some snow pants, and probably boots and a knit hat instead of a floppy hat. However, you can probably still keep that sunscreen and sunglasses because you have the same radiation environment. So the big takeaway is, much like we're doing spacesuit design, you can have similar tasks, but very different environments, so it affects how you design your spacesuit. For the Artemis program, we have two very different environments. One is on launch day, and one is on the lunar surface. So we actually have two different spacesuits that we're going to talk a little bit about now. So that is the OX. That is the Orion Crew Survival Spacesuit. And this suit is dedicated for use on the Orion spacecraft. And the Orion is the one that's going to take off from Cape Canaveral in Florida and fly our crew all the way to the moon. And at the end of their mission, it's going to fly them all the way back home. And so when we think about where you're going, most of the time when you're in the Orion capsule, or you're just outside of it, whether at launch or at landing. And so we really have to think about those environments when we design the OX spacesuit. We also have to make sure that this is our suit that's keeping us safe when all those dangerous things that could happen in spaceflight at launch and landing. The suit has to be designed to help the crew survive those scenarios. And there are special features that help it do just that. So we think about the things that could potentially go wrong on the launch pad. So if you need to quickly get away from the vehicle before you launch, but you're on the launch pad, the crew needs a lot of mobility. And so this suit is designed to operate when it's not pressurized. It has a lot of mobility. It's very lightweight. The material itself is flame retardant. And then you also have to make sure you have good visibility and that you're able to see your friends around you when you're getting out of the vehicle. So you have the helmet has a lot of visibility through it. It makes it easy to see, but you can also keep it closed. So if there's smoke around you, it doesn't get into your eyes. You also have extra oxygen bottles here on the leg of the spacesuit, and that provides you some breathable air until you get to a clean, safe space. You also have lights that go in the sleeves of the suit. That way, if it's a little bit dark, you can see your other crewmates, and also the rescue team can help find you quickly. So there's a lot of safety features built into the suit to specifically support launch day. Most of the time when you're wearing this suit, though, hopefully you'll be actually in space. And so when we think about that, you can see this is a picture of one of the early prototypes of the Orion spacecraft with the crew seated inside. On launch day, you have to lay on your back. So when we design all the insides of the spacesuit, we have to make sure that it's comfortable when you're doing that. And so that dictates where we place all the different connections for your air and cooling loops. Also, you're going to be wearing a seatbelt, so we had to make sure that we put all of those connectors in places that won't interfere with your seatbelts. And then on top of that, you can see the control panel that's overhead So we need to make sure that your helmet allows you to view all of the controls, that you have enough reach and mobility in your shoulders to reach all the controls on the control panel, and as well as dexterity in the fingertips to actually control the displays. Then after your mission, you're landing in the water with the Orion. And so the suit has to help you with that scenario too. And here you can see part of the crew testing we did off the coast of Florida, looking at different ways and different parts of the suit that can help you stay safe in those scenarios. So you can see you can either get out of the vehicle by going through the side hatch, and there is a life raft that you go from the vehicle and hop into your life raft. Now, if that isn't an option, the second way you can get out of the Orion vehicle is to go through the top hatch. And in that case, we tested it with and without the life raft. If you don't have a life raft, on your spacesuit, it has a life preserver that you can yank the handles and it inflates. So if you go into the water, it keeps you safe there too. Another cool feature about this suit is that bright orange color. It's a great color, but it's also there for safety. The bright orange is very easy to see in the water. So if you have the crew that's in the water, the Navy can see them easily and help pick them up. Additionally, you have specific handholds that are built into the suit so that if they need to be rescued, it's easy to pick people up by those handholds. So a lot of those safety features, every part of the spacesuit is very well thought out, and so that you can quickly find people, keep yourself safe, and have a comfortable time when you're doing your job. Now, the second suit, it's really different because again, you ask yourself, where are you going and what are you doing? For the XCMU, that means we're going to the surface of the moon and we're doing exploration and science tasks, which is very different from what we just saw that we were doing with the Orion suit inside the Orion vehicle. So here's a quick introduction to our XCMU. So you can see it already looks very different from the orange suit that we use in the Orion vehicle. That's because this suit, like I said before, it's for working outside in the middle of space. And that means it's dedicated for spacewalking. It has a modular design, which means you can move the bits and pieces around to give it the best configuration of mobility and life support systems so that we can do spacewalks on the International Space Station, on the lunar surface, at the Lunar Gateway, which is the one that's orbiting around the moon, and also for deep space transit. We have a single EVA suit that can meet those overlapping mission design needs, as well as keep them safe from the environment around them. When we talk about the XCMU, it's a really complex machine. And so we talk about it in two different subsystems. So one is the portable life support system that you see on the left. And that's basically the brains of the spacesuit. It has the power supply and a lot of the other big major systems you need to keep the astronaut healthy, happy, and functional. The second system is the pressure garment subsystem. And that's this part. It's the human-shaped one that has all the mobility features. So let's go a little bit deeper about what each of these systems do. So the pressure garment, it's unique from all of our other spacesuits in a lot of ways, but one of the biggest ones is that it's actually a rear entry. So you can see in the picture to the left, that's the back door of the spacesuit. So to put it on, instead of like a pair of pants and a shirt, the pants are always attached to the top part of the spacesuit. You open the rear door, put your feet in the inside, and then slide down and close the door behind you. So it makes it a lot easier to take it on and take it off, as well as giving you more mobility in the spacesuit itself. It allows us to fit a broader range of people, from very small people to very tall people. We can fit a lot more people with a suit of this type of design. It also allows you to have greater flexibility in your shoulders, so you can do all sorts of tasks very easily without being injured. And it gives you a lot more mobility in the pants, the lower torso assembly of the spacesuit, so that we can do some of the tasks that I'll show you in the next slides. Another big thing about this spacesuit that's different from ones in the past is the moon is very dirty in terms of it has a lot of loose soil that floats around, and that gets stuck in your spacesuit. So we had to design this suit specifically to be tolerant of all that extra dust so that it can keep working and help astronauts do their jobs as they collect rocks and science samples and set up experiments on the lunar surface. So here's an example where we took one of our prototype spacesuits out to the desert. I'm going to play this so you can see what it looks like to have a walking spacesuit. Oops.
Head down in the crater.
So this spacesuit, it's about 120 pounds, this particular one that we tested. And so you can see it's pretty easy to walk. They're using tools. They can travel and take samples of the soil around them and perform the scientific tasks. We train our astronauts to act like real geologists here on Earth because we have to do a lot of the same type of science collection. That means taking samples of the rocks, taking photos every time you pick up a rock so you understand how it fits into the bigger picture of science. And then also, we're learning how to do things very sterile so that when we go to Mars, we can also collect samples that might have biological significance. And we want to do that very carefully. And so we're practicing all those techniques here on Earth. And as we learn things from practicing here on Earth, we can modify the design of our spacesuit to make it easier for astronauts to do those same jobs when they go onto the moon's surface. And this video that I'm about to show you, so you can see up in the upper corner, this is the Apollo spacesuit. And it moves very different from this planetary spacesuit, which is in the Argos, which means we've reduced the gravity so that he's moving in the same gravity as you would have on the moon. And so you can see that with the new spacesuit, we're able to bend down easily and pick up the sample container. And it's more of a walk, whereas up in the top corner, he's definitely hopping, trying to move closer and hammer. And as he falls, he tries to kneel down and becomes a fall in the Apollo suit, whereas you're able to have a very controlled kneel and then stand back up in our new spacesuits. And a lot of that is how we design that mobility. You can see that in this suit, we have bearings in the hip, and that means that it's very easy to kneel down. In the Apollo spacesuit, they didn't have the bearings in the hips. And so it's kind of like working inside of a big inflated balloon. If you've ever tried to bend a balloon, it gets really hard because the pressure inside has to move around and go someplace. Whereas if you use a bearing, you're not changing the volume of that joint. It's a constant volume joint, which means it's very easy to move for the human body. And so we have to think about this, thinking about tasks. How often are you going to kneel? How often do you need to pick something up? And by knowing more about the jobs we want to do on the surface, what we're doing, we can make sure that we design the right mobility systems into our spacesuits to start with. And the big trade-off there is every time we add a little bit of mobility features, such as a bearing, it does add some mass to your spacesuit. And we don't want those spacesuits to be too heavy, because while it is less gravity than there is on Earth, we still have to launch it. And it takes a lot of power to launch mass off of the Earth, but you're also carrying that around in your back every day when you're doing spacewalks. So we want to try to make everything as lightweight as possible. And part of that is really understanding the trade-off of how much mobility do we get for each feature. And as we do tests like this one, we can learn a lot more about our systems and what is necessary, what is nice to have, and what do we not need at all. And so that's why testing is really important and really understanding the tasks that we're going to be doing when we get to the lunar surface. Now, we talked about the moon, but equally important with this spacesuit, the XEMU also needs to be able to do spacewalks on the International Space Station. Now, we saw walking on the moon was much like here on Earth. You're walking with your feet. But when you get to the International Space Station, you're actually walking with your hands. All of your moving around is through handrails, as we'll see in this video. So you can see the yellow handrails that the astronaut is training in the neutral buoyancy lab, which is the big giant swimming pool where we have the space station and the astronauts do all their training in microgravity. And you can see as she moves, she has to have a lot of mobility in the shoulders of that spacesuit. And so when we think about what direction we need to pick up, it's not just picking things up off the ground, but actually being able to walk across those handrails on the space station. The other part that's different about the space station compared to working on the lunar surface is that there are a lot of tight spaces. When the space station is a man-made object, so that means we assembled it up there, it's a lot of different pieces kind of put together like Tinker Toys. but that makes it tighter. You don't have as much room to move around when you're doing your spacewalk. And so one of the things that we're testing is with our spacesuit that we want to do all these different jobs, make sure it can still get it in and out of the International Space Station airlock. And so this is video from one of the tests that we did there.
Straight up.
So this represents
Wow, look
the
at
crew
you.
member actually coming back inside of the airlock. So you can see the hatch that is behind them, and they're coming inside and have to reach forward for the control panels. And it's really important because, again, we're not changing the design of the space station. So we need to make sure that the spacesuit can fit within the design that we've already built. And it was a lot of really good testing that we did with several different sized people to make sure that we had everything right. And as we make tweaks to our spacesuit design, we come back and test that pressure garment again to make sure that it all works together. The other part of the spacesuit system is a very important part. The part that I told you was the brains of the spacesuit. And that's the portable life support system, the big backpack on the back of your spacesuit. This is where it's doing all the important work. It has the batteries that power your spacesuit. It has the oxygen that you need to breathe, because if you're outside with that oxygen on the moon, you're out of luck, because we need oxygen and there isn't any in the vacuum of space. It also provides the pressure that's in your spacesuit to keep all of your organs functioning properly. In addition, you need to stay cool, because we talked about protecting you from the extreme cold and hot temperatures that you have when you go on a spacewalk. And we do a good job on the pressure garment side, making sure that we insulate you so it's kind of like a thermos. But as you start to work out, you're going to build up body heat. And so we use the life support system to help take that heat away and kind of be like your personal air conditioning system. And so that all happens in the back of that backpack. We also have what we call a CO2 scrubber. So when you're breathing, you always exhale a little bit of carbon dioxide. And we can't use carbon dioxide to breathe. So we need to scrub that out so that when we inhale, we're having a lot more oxygen than carbon dioxide. And so we have a scrubber system that's constantly cleaning the air that we breathe and recirculate through the spacesuit. Another key component that's really cool in this one is we have a new control system. That's the black and red picture that you see here. And this little box goes on the front of your spacesuit, and it controls all your systems from the volume inside your headset to your microphones to turning on all the fans and the pumps and everything inside your spacesuit. And this is the smallest one we've ever made. So that means that we can have a lot smaller people in our spacesuits too. So it's a really neat system that keeps everything alive. And on top of that, we've made it modular. So it's kind of like the computer motherboard. As we have new technologies, we can swap things out really quickly and easily. So it makes it a system that can evolve with us. As our mission changes, we do different tasks. As we do different complexities, we want new features, we can easily swap things out so that our suit can evolve with us as we go from the moon and on to Mars. And so lastly, I just wanted to leave you with a few websites here. We have a whole website about spacesuits if you'd like to see that. That's nasa.gov/suitup. But you can also find out more about the Artemis program by following us on Facebook, Twitter, and Instagram. And so with that, I'm happy to answer any questions you guys have about spacesuits or the Artemis exploration program.
Wow, this was an amazing presentation. And I just wanted to say thank you, Lindsay, for sharing your expertise. So now we are going to go ahead and invite some of the students to ask you some really cool questions. So looking through, so it looks like Manuel has his hand up. So Manuel, if you want to go ahead and unmute yourself, you can go ahead and ask Miss Lindsay a question.
How does the spacesuit work? You're muted. You're muted.
Thanks. I'm so bad about that. I appreciate the reminder. But yes, so the spacesuit, the first thing you do is when you put it on, once you're inside and you close that door behind you, you're going to use your control system to turn on the fans and the pumps. And as you turn those on, it's going to start to bring oxygen inside of your spacesuit, and it's going to inflate it. And all that air stays inside because the spacesuit's kind of like a big balloon in some ways. It keeps all the air around you. And then it has those different mobility features to help you do your job once you're safely inside.
Okay, so it looks like Chevelle has a question. If you want to go ahead and unmute yourself, we can get your question asked.
Oh, louder, please. A little louder, Chevelle.
So I was wondering, when can children go to Mars with astronaut suits for kids and adult sizes?
You know, that's a really great question. I know that I would love to be able to go to Mars too. I think part of that's going to take a while. We want to send astronauts there first to make sure everything is safe and set up and build the habitats that we need before we can have other people go. But from a spacesuit design perspective, we're learning a lot about how to build spacesuits in all different sizes. I think with all the technologies that we have today, we could build a full fleet of spacesuit sizes for anybody so that when we're ready to do those missions, we'll have the spacesuits that would fit anyone.
Thank you.
Okay, so it looks like Nora has a question. If you want to go ahead and unmute yourself.
Why at daytime in the moon it is hot?
Are you asking, sorry, the moon is hot?
At daytime, why is the moon hot at daytime for the moon?
Yeah, the moon gets hot just the same way that Earth does. As the sun, as the part of the moon faces the sun during the daytime, we have what's called radiative energy. So the energy from the sun, it travels to the moon, and that energy becomes heat when it's absorbed by the rocks that are on the moon. So it becomes very hot. But what's interesting, even during the daylight, if you go to a place that's in the shadow, it can be very, very cold. So it can be 250 degrees in the daylight. And then if you go into the shadow, it can be negative 250 degrees. It's a big temperature difference. And so it's really important to design your spacesuit for both hot and cold temperatures.
Wow, that was a really great answer. So, Lindsay, we have a question from the chat. Yanielle wants to know, how long does it take to build these spacesuits?
Well, for us, we've been working on this design for about 5 years now, actually. But once we finish the design to make a suit, once we've worked out all the different ways, we know exactly what we want to build, it'll probably take us about 1.5 years to build a full spacesuit. What's great though is because we can build it in pieces and change out the stuff that works well, we keep that, and if it doesn't work, we can change out the bits that don't work until we can build a little, test a little until we have the perfect spacesuit. But this one we've been working on for about 5 years now.
Okay. Should we give
Wow,
Alexander a chance? Alexander from Ms. Muller's class. Go ahead and ask your question, Alexander.
I just want to say that, can we land on a star, or like we're big enough but we can't land on a star? Like we're big enough to land on a star but we can't really land on a star.
That's a good question. Most stars are actually gas. And so if a gas would be like, if you're boiling water on the stove and you see the steam that comes off the top of the water, that's what a gas is. And so it's not solid enough for us to actually stand on. And most stars are primarily gas like that. So we could probably visit a star, and we've sent satellites that have gone to stars. But it's mostly gas, so there's not a lot of place for us to actually land since it's not a solid surface.
No, I'm talking about matters of size. Like we would be big enough but we can't really land on it since it's completely gas.
Yeah, just like our closest star is the sun. The sun is a really big ball of gas. It's also really hot. So I don't think we'll end up going there with humans anytime soon.
Thank you.
Okay, Doc, let's do one more question.
Sure. Let's Victor Gutierrez, I guess Miss Nayal, the teacher, Nayal, I believe. Oh, speak a little louder.
Join other planets.
I missed the first part. If you could talk loud, something about other planets.
Yeah, are you gonna study other planets?
We are going to study other planets. So when we go to Mars is the first place, and getting there, it's going to be pretty hard for humans, but we're really excited to be doing that after we go to the moon. And so I think the way that we like to do exploration, we go one place and we learn all about it, and then we send robots. So like you might have seen recently, we sent the rover to Mars first. And so the rover's there to kind of scout out and give us an idea of when we send humans, where do we want to go and what are we trying to find? And so we're going to send humans to Mars next. And then once we learn all about Mars and we've learned what we want to learn from there, we can send and repeat that on other planets. We don't have a plan to do that today, but I think that would be definitely very exciting as something to look forward to after we go to Mars.
All right, thank you. Thank you so much. Lindsay, I learned so much. Thank you for an incredible talk. And can we all please give Miss Lindsay Aitchison a nice round of applause? Virtual, wasn't this amazing? I learned so much. I know you did too. And let's do this, okay? So that we can take a photo with Miss Aitchison. Can everyone open up your cameras? Okay, Mr. Natividad, are you there?
Yes, I'm here.
Okay, can we set it up so that we can see the, oh, here we go. I see it now. I just had the wrong view. Okay, so let's see. Let me now make sure everyone has their camera open. Serena, are you gonna join us in this photo? All right, ready? Smile, big smile, 1, 2. Okay, let me see before we go. Hold on 1 second. Ah, that's a nice photo. Okay. All right. So once again, Miss Lindsay Aitchison, my colleague, who I work for now for a number of years, and I learned so much about what you do, Lindsay. This was amazing.
Thank you guys so much for having me, and thank all of you for such great questions and for paying attention. I really appreciate it.
Yeah. And remember everyone, boys and girls, remember why we're doing this. Okay, we're doing this because you're all special. Miss Lindsay Aitchison needs help, and so do I. You have to do all your homework. You have to do well in school, listen to your teachers and your parents, and then grow up, go to college. And when you're done with college, you can come and help us. We need your help, okay? Is everybody gonna come and work for NASA? You're gonna come and work with us? Because we need help. We need you to do well in school and hurry up and come join us, okay? All right. Well, don't go yet because I want to share with you guys that we have another incredible talk tomorrow. So let me see. Let me figure this out. Okay. Remember to come back tomorrow because tomorrow we're going to have Mr. Chris Moore, who is going to talk to us about houses in space. He's responsible for building what we call habitats. Okay, but they're really houses in space. So tomorrow you're gonna learn all about that. Okay, so remember to come back tomorrow at the same time. Who's gonna join us? Everybody come back, okay? Tell your friends. This is really, really cool. And this is special just for you guys, okay? So with that, we're going to finish this session. I'm gonna thank everybody, Allen Brock Union School District, Mr. Natividad, Ms. Martinez, and then the Ames Public Affairs Office through Danielle's support today. Thank you very much. We're going to end this session. Thanks, everyone. Remember to take care and don't forget to do your homework, okay? All right, thanks. Bye-bye.